Assalamu alaikum and good evening, everyone. Today we are going to start October-November 2023 paper 2-1. Now start from question number 1. The element phosphorus, sulfur, and chlorine are in the period 3 of the periodic table. Okay. Table 1.1 shows some properties of the elements phosphorus to chlorine. The first ionization energy of sulfur is not shown. Okay. Okay, Omar Sabir, let me see. The number of elements in 3p subshell. Okay. So if we look at phosphorus, phosphorus is in group 15. So it's, if you recall, it's over here 3p3. For sulfur, it's 3p4. And for chlorine, it's 3p5. When you will write its whole electronic configuration, you will find it like this. Okay. So it means 3 electrons over here, 4 electrons over here, and 5 electrons over here. Is this clear? Now, total number of unpaired electrons. So if you recall in 3p3, when we have a 3p3, so 1, 2, 3, all 3 electrons are unpaired. In p4, 1, 2, 3, 4. So 2 electrons are unpaired. And in p5, 1, 2, 3, 4, 5. So 4 electrons are unpaired and 4 electrons are paired and 1 electron is unpaired. Is this clear to all of you? Yes, if any one of you has any query, please ask. Okay. Now A1. Complete the table 1.1. Show the number of electrons in 3p subshells and the total number of unpaired electrons in an atom of phosphorus, sulfur, and chlorine. We are done with this. Construct an equation to represent the first ionization energy of phosphorus. So if you recall the first ionization energy of phosphorus, so must be a 1 mole of phosphorus atoms in the gaseous state, which turns to form 1 mole of phosphorus plus 1 gaseous ion and a loss of 1 mole of electron. Okay. Now, 3 possible values for the first ionization energy of sulfur are given. Circle the correct value. Explain your choice by comparing your chosen value to those of phosphorus and chlorine. So if you recall, that it's group 15, it's group 16, and it's group 17. So from group 15 to group 16, there is a decrease in the ionization energy because of having a 1 pair of electron, which causes spin pair repulsion. And then to in group 17 element, there is again increase in the ionization energy, right? So if you see, this one is 1060 and this one is 1260. So this must be lower than both of them. So 1160 is greater, 1320 is also greater. So that must be lower. So I'm going to encircle this answer, this option, that 1000 kilojoule per mole. And now I have to explain the reasoning. So I'm going to write that explain your choice by comparing your chosen value to those of phosphorus and chlorine. Okay. So here I'm going to write that in sulfur, the nuclear attraction is lowest as compared to phosphorus and chlorine. That's why, see, its energy or its ionization energy would be smaller than both of them. Is this understandable? Okay. Then uh, sulfur has a stronger nuclear charge than phosphorus. And see, it is because phosphorus has 15 protons, sulfur has 16 protons, and chlorine has 17 protons. So phosphorus has a nuclear charge stronger than sulfur has stronger nuclear charge than phosphorus. But in sulfur, 2 electrons are paired in P, while in phosphorus, all 3 electrons are unpaired in P. Is this understandable? Now, and with chlorine, I can just state that chlorine has a stronger or greater nuclear charge than sulfur. Yes. So see, first we have decided that sulfur's has a smaller value, and then we explained the reason that obviously if the values is smaller, then the nuclear attraction of in sulfur would be smaller than these. Now the reason that sulfur has a stronger nuclear attraction than phosphorus, but as the pair of electron which causes spin pair repulsion, which makes it, uh, to have a lower attraction. Just give me a minute, please. Okay. So, and we have explained the reason also that sulfur has a stronger nuclear charge than phosphorus, but the ionization energy would be lower because of having a pair of electron which causes spin pair repulsion. And in phosphorus, there are all electrons are unpaired. And then with the chlorine, it's simple that chlorine has a stronger nuclear charge than sulfur. That's why chlorine has a, higher ionization energy than sulfur. Okay. Now, B part. Phosphide, sulfide, and chloride have the same number of electrons. Okay. Give the electronic configuration of phosphide. So if you look at phosphide 3 minus, so it means that as an atom, in phosphorus atom, there are 15 electrons and it's a 3 negative charge ion, which means it has a 18 electron. So I'm going to write the electronic configuration for the 18 electrons. 1s2, 2s2, 2p6, 10 electrons are done, 3s2, and then 3p6, all 18 electrons. Is this clear? Okay. Now, state the trend in ionic radius shown by phosphide, sulfide, and chloride. So if you guys recall, if this is the ionic radius of phosphide, then the ionic radius of sulfide must be lower than that, and the ionic radius of chloride even lesser than sulfide. And it is because as we move from phosphide to sulfide to chloride, the nuclear charge increases and the number of extra electrons decreases, due to which there would be lower attraction, lower repulsion between the valence shell electrons, and as a result, the size decreases. So, uh, the ionic radius from phosphide to sulfide to chloride decreases due to increased attraction between nucleus and valence electron. It is because nuclear charge is increasing and shielding effect remains same. Yes, is this clear to all of you? That as we know, when we are moving, it's 15, it's 16, and it's 17. So see, as the size is getting smaller, which means that there is a stronger attraction. And if the attraction will be stronger between the nucleus and the valence electron, it means, and we can justify it, it is because the nuclear charge is increasing. And as the number of shells, the inner shells, the total number of shells remains same, so the shielding effect remains same. Okay. Now, C part. A student does 3 tests on separate samples of sodium, aqueous sodium chloride. Complete table 1.2. The observation with this table 1.2 with the observations the student makes in each test. Okay. So addition of a bromine, it means that there is a reaction between sodium chloride and bromine. Does this reaction occur or not? Yes. If you recall, the reactivity of the halogens decreases down the group. So bromine is below chlorine, so it means that bromine cannot dissolve, cannot displace chloride from its compound, right? So we are going to write over here, no visible change, or either you can write no reaction. Is this clear? Yes, is it clear to all of you? Okay. Then addition of few drops of concentrated sulfuric acid. So if you recall, when few drops of concentrated sulfuric acid are added to a sodium chloride, no, it's not a neutralization reaction, that is already a saltomer. So yes, very good, Hassan. No change would be seen. And if we add more amount of sodium concentrated sulfuric acid, then in that case, the hydrochloric acid is formed as a gas, and we would write that the steamy fumes has been seen, right? Because we are adding everything into a sodium chloride. So with the sodium chloride, few drops would not make any change. Okay. Now addition of a few drops of silver nitrate. So when we do add the silver nitrate, we know there are chloride ions, and silver chloride is insoluble compound. So as the silver nitrate has been added, we are going to observe a white precipitates, and these white precipitates are of silver chloride. So you are going to observe white PPT over here. Is this clear to all of you? Okay. Now D part. POCl3 shows similar chemical properties to PCl5. Okay. POCl3 has a melting point of 1 degree Celsius and a boiling point of 106 degrees Celsius. Okay. Reacts vigorously with water. See, they are saying reacts, forming misty fumes and an acidic solution. Explain how the information in D suggests the structure and bonding of POCl3. Now you have to justify. Which one, Anshara? That is the test that you have been studying since your O levels or IGCSE. That when we add aqueous silver nitrate and we got the white precipitate, it's the chloride, and that is the test that you were doing in paper 3 as well. The test for cations and anions. Okay. So if you look at the melting and boiling points, they are low, which suggests that it's a simple molecule, right? And if it's a simple molecule, then there would be weak intermolecular forces between the molecules. And as it reacts with water, which means it is being hydrolyzed in water, that it is undergone hydrolysis, and which suggests that, there are a covalent bonds. Okay. So the melting point and boiling point are low. Indicates simple molecular simple molecules having weak intermolecular forces between them and reaction with water is hydrolysis, indicating covalent bonds. Is this understandable to all of you? High melting point and high boiling point would be the temperature like 500, 600, 700. These are when the melting point is like this, then it is considered is to be high. Okay. Now, construct an equation for the reaction of POCl3 with water. Okay. So when POCl3 reacts with water, we know phosphoric acid is formed, H3PO4 and HCl. Now you have to balance the equation. There are 3 chlorine, so there must be 3 hydrogen, 3 chlorine over here. So as a result, you got 6 hydrogens on the right side. So you will put 3 over here. Now if you see, the equation is balanced. Okay. Now third part, POCl3 contains a double covalent bond between phosphorus and oxygen. Okay. Complete the dot and cross diagram in figure 1.1. Show the bonding in POCl3. Shows outer shell electrons only. Okay, so they have told you that there is a double bond, right? Here we have a single bond in all of them. Okay. Now, phosphorus has a 5 electrons, so all those 5 electrons are shared. Chlorine has 7 electrons in the outermost shell. One is shared, so 6 are left. So we are going to put 3 pairs around the chlorine atom. In the same way, 3 pairs around the chlorine atom over here. And over here, oxygen forms 2 bonds, and oxygen has a 6 electrons in its valence shell. So out of 6, 2 electrons are shared. So 4 are left. So we are going to show 2 pair of electron over here like this. Is this clear? Okay. Now, E part, POCl3 gas forms when PCl3 reacts with oxygen. Okay. Table 1.3 gives some relevant data. Okay, enthalpy change of formation of PCl3. It means they have provided us this value. Enthalpy change of formation of POCl3. Okay. Sorry, it's not Cl2. And over here it's oxygen. This one. Okay. It's a bond breaking. 1 mole of. So if we divide, it's a bond energy. And if we divide it with the 2, okay, just keep it bond energy. Now, if you see, okay, define the enthalpy change of formation. So, if you define, it is the enthalpy change when 1 mole of a compound is formed from its elements under standard conditions. Okay, and they ask you just the enthalpy change of formation, so there is no need to write the standard conditions, but the elements must be in their standard states. That is important. So it is the enthalpy change when 1 mole of compound is formed from its elements in their standard state. So the elements must be in their standard state, and I'm not going to mention standard conditions because they didn't ask you for the standard enthalpy change of formation. Is this clear to all of you? If any one of you has any confusion till here, please ask. Calculate the bond energy of phosphorus oxygen bond in POCl3 using the data in table 1.3. Okay. So you have to find the bond energy. PCl3 reacts with oxygen. Okay, and they have used 2 moles of PCl3, right? So we got 2 moles of POCl3. And if you see over here, they are asking you the bond energy of this, right? Yes, Hassan, your definition is also correct. But you have to mention that 1 mole of elements in their standard states. Okay, so we have to find this value. Okay. So we have a minus 289 for PCl3 and minus 592 for POCl3. And that is when oxygen molecules turns to form oxygen. That is 496. Okay, look over here. They didn't give you any other value, right? So it's also a gas. Phosphorus, chlorine, and oxygen. So when they react to form PCl3, the change would be minus 289. There are 2 moles are formed. So 2 times minus 289. Then here POCl3 is formed and its change would be minus 592 and 2 moles are being formed. So 2 times minus 592. Okay. And if I make it X, so am I able to calculate the enthalpy change of formation for this reaction? Oh, sorry, enthalpy change of reaction, delta H. And if you look at the Hess's cycle, this is the indirect route and this would be the direct route. So the expression would be 2 times minus 289 plus X is equals to 2 times minus 592. So if I calculate the X, so X would be this enthalpy change for this reaction, right? And it is equals to 2 times minus 592 and then minus 2 times minus 289. Can anyone solve it and tell me the answer, the enthalpy change, this delta H, that what it is? It's minus 606. Is this understandable to all of you? Now, if you recall the formula of the another formula, that the enthalpy change of reaction or the enthalpy change would be bond broken, the energy involved in bond broken minus the energy involved in bond formed or bond made, isn't it? So if you see, here we got PCl3, which means there are 3 phosphorus and chlorine bonds and which are already over here. So these bonds are formed and then these bonds are broken and then these bonds are formed. So the net change for these would be, there would be no change. The bond which actually broken is this and the bond which actually formed is this. Is this understandable? So the enthalpy change is minus 606. The bond broken is oxygen and its bond energy is given over here, see, positive 496. Then the bond which is made, we do not know its bond energy, it is X. Now calculate the value of X. So if I'll move the X, so X is equals to basically, if I'm using this equation, so there are 2 moles, so it is going to be 2X. So 2X is equals to 496 plus 606 and X is equals to, if I add them to 9, 10, 0, is it 1102 divided by 2? So it is going to be positive 551. Is this clear? Okay. So for today, we are keeping the class till here. And tomorrow from here, we will start and complete this paper. Okay. So see you everyone in the next class. Take care. Goodbye and Allah Hafiz.